Okay, last block day was Intro to Sequences and Series. That was worksheet 1. I feel like that was pretty easy. That was just like recognize the patterns, introduction to the symbols and the notation. Not a big deal. Friday we did arithmetic, worksheet 2, and sort of the main only thing you had to memorize was the sum formula for an arithmetic sequence. So there's Friday's notes in one line. Obviously there was a little bit more to it than that.
Do you need to know like the other one, like n minus 1?
So the other one, it's like, do you need to know that, or can you figure that one out? I say you don't need to memorize that. I say it's easier to just figure it out, because if you're starting at the first term, then how many steps, that thing. So you don't need to memorize that one. You do need to know this one. Okay, so today is geometric sequences and series. A geometric sequence is one whose consecutive terms have a common ratio as opposed to a common difference. Common ratio as opposed to a common difference. You can just skip down to this arrow right here. To find the common ratio, take any term in the sequence and divide it by the preceding term. So A2 divided by A1, or A3 over A2, or A81 over A80. It doesn't matter. Any term divided by the last term gets you the ratio. Number 1, write the first 4 terms and find the common ratio in the geometric sequence given by 3 times 2 to the n. Okay, first one back, so we'll do a slow it down, write out the n's, write out the a's. So if n is 1, that means plug in 1. 3 times 2 is 6. I need like one more line in my table for a reduced format. If I plug in 2, 3 times 2 squared. Remember, it's 3 times 2 squared, not 3 times 2 squared, right? Order of operations. 3 times 4 is 12. 3 times 2 cubed. 2 cubed is 8. Times 3 is 24. And then if we plug in 4, 3 times 2 to the 4th. 2 to the 4th is 16. Times 3 is 48. Although maybe at this point you start looking at your terms and realize what's going on. You're doubling it, which means your r is 2. You're multiplying by 2 each time. Number 2, write the first 4 terms and find the common ratio in this sequence. So maybe not spelling it out quite so slowly this time. 4 times 3 to the first, 12. 4 times 3 squared, 9 times 4 is 36. You reckon the ratio is 3. So the next one is just 36 times 3. 108?
Yeah, 108.
I think. 18 plus 90 would be 108. 4 times 3 to the 4th. I don't know, but if I could just multiply by 3, this one's easy. 324. And so this one we picked up on the pattern a little quicker because we were looking for it and we knew what we were looking for. R was 3. And so kind of instead of plugging in n, once we got a couple, we're like, well, let's just multiply by 3 to get the next term. Number 3. Maybe we should write these out again because we got a fraction here. First 4 terms in the common ratio for negative 1/3 to the n. Okay, so negative 1/3 to the first. I can do that. How about negative 1/3 squared? Wait, say that again? Positive or negative?
Positive.
Positive.
Okay. Positive, that is positive.
1/9. Negative 1/3 cubed. Negative 1/27. And then I don't even know that you would write negative 1/3 to the 4th because you maybe figure out what's going on here. So instead of looking at a formula, you look at your terms. What's the next term going to be? Positive 1 over what?
1 over 81.
81. So what's my common ratio for this one? What am I multiplying by each time? Negative 1/3. Negative 1/3. And so kind of look back at those 3 examples, and can you figure out what R is?
It's just the number with the n.
Okay, the number with the n. The number with an exponent of n. Throw in one extra word there. But yes, it's the number that's getting raised to a power. That would be the R. Because that exponent determines how many times you multiply, and so that makes whatever has the exponent the common ratio. Sequence given by 5, 10, 20, 40. Okay, clearly a geometric sequence with common ratio 2 because you're multiplying by 2 each time. If you take any term, divide by the term before it, you get 2. Yes, that's what it means to have a common ratio of 2. Another way to think of it is, what do I multiply each term to get to the next term? Like, well, 2, we just said that. Okay, so here's the writing of formula thing. And again, there's the figure it out way, and then there's the formulaic way. And I think once you understand it, the figure it out way is faster. So we'll kind of learn that way, and then I'll give you the formula at the end. So it has the parallel with the arithmetic where there's a formula, but you can also think about how many steps is it from the 2nd term to the 8th term or whatever. Okay, we know the common ratio is 2, so I know I'm going to have 2 to the n somewhere in my formula. However, it is more convenient to start, in quotes, with the term n minus 1, because if you plug in 1, what's 2 to the 0? 1, and so your multiplier is 1. It makes getting your first term super easy if you'll use n minus 1. So what multiplier do I need out front if I want to land at 5? 5. Because it says the answer down there. Yes. The other way to do it is if you left 2 to the n, then your multiplier out front would have to be like 5 halves. Because if you plugged in 1, you would want the 2's to cancel to land at 5. So that works, but it's a whole lot easier to use the n minus 1 thing. If you use the n minus 1, then your first term is whatever that multiplier is, or the number out front. In fact, here's the formula. So again, this is one where you can memorize the formula, or you can be like, I can just figure it out, as long as we use that r to the n minus 1. Again, some people will memorize the formula, other people will just figure it out every time. And you can do either one. All right, write the explicit formula for the nth term in the sequence, meaning I want a sub n equals and have a formula. And then once I have the formula, I'll just plug in 8 and see what we get. Okay, so job 1 is, what's my common ratio? And you can pick any term and divide it by the previous term. It's like negative 8/12, or, excuse me, negative 12 over negative 18. But all of those are 1/3. Or 2/3 even. Right, I'm multiplying each of them by 2/3. Which means my sequence should probably have a 2/3 to the n minus 1 in it. And again, the nice thing about using n minus 1 is that then that number out front is just the first term. So in some ways it's easier than the arithmetic one, because the arithmetic one you have to figure out what number goes there. In geometric, if you'll use the n minus 1, then you can just grab your first term and go from there. Oops, 8th term. So A8, negative 27 times 2/3 to the 8th. Oh, that's going to be lovely. Whoops, not to the 8th, to the 7th. Didn't make that mistake on purpose, but it is a common mistake. I plug in 8 and I do 8 minus 1 and get 7. So 2 to the 7th over 3 to the 7th. Although I think I can, 2 to the 7th isn't terrible. All right, you can just count them up if you need to. 2, 4, 8, 16, 32, 64, 128. 27. It's like, wait a minute, that's a power of 3. So I can kind of simplify my life here, rather than figuring out what 3 to the 7th is, which I don't really want to do. I can look at 3 cubed over 3 to the 7th, and that would make 3 to the 4th in the bottom. And that's a whole lot easier than 3 to the 7th. 3 times 3 is 9, times 3 is 27, times 3 is 81. So that was kind of a pain, but it had a little bit of a trick built in there. If you recognize that 27 is 3 cubed. Wait, you mean I do expect very highly of you? I mean, I will plead guilty to that. I do expect very highly of you. Yes. And I think rightly so. Number 5. Write the explicit formula for the nth term in the geometric sequence with first term negative 3, common ratio negative 2, 11th term. This seems pretty similar to number 5, so why don't you try number 4? Okay, number 6. Here we go with this stepping around business. Like if you're on the first step and you want to get to the third step, how many steps is it? Number 6, the second term. I like writing this stuff out. So A2 is 20. The fourth term is 180. What is the first term if a sub n is greater than 0 for all values of n? Okay, we'll worry about that in a minute. So how many steps is it from the second step to the fourth step? How many times you got to step up? 2. So if I start at 20 and I land at 180, I need to multiply by r twice. Right? If it helps. Right? There's the second term and the fourth term. So I need to multiply by r twice. Here's the kind of the picture of what's going on. 20 times r squared lands me at 180. So r squared equals 9. Oh, that was nice of them. So r equals, if r squared is 9, plus or minus? Plus or minus 3. Now, the second statement, what is the first term if a sub n is greater than 0 for all values of n? So a sub n is always greater than 0. So then r has to be positive. So I can throw out the negative one. R is just going to be positive 3 to make this work. So I guess I could fill in the blanks to make sure it makes sense. I don't have to, but it wouldn't take long. 20 times 3 times 3. So I feel good about that. So how do I get backwards to the first term? Yeah, just divide by 3. And 20 divided by 3 is 20 over 3. Some people will almost always draw these little blanks because it helps them count how many steps there are, and that's completely okay. Like if that helps you keep things straight, by all means do it. Number 7, the fourth term is 125. 2, 3, 4. And the 10th term, I guess here's the trouble is you got a 5, 6, 7, 8, 9, 10. 125 over 64. What is the 14th term? If the series is alternating in sign. Oh, so now we're going to have an RB negative in order to accomplish that. So 125. All right, how many steps is it from the 4th term to the 10th term? 6. Yes, 4th, 10th is 6. Again, if you need to, then you kind of draw them out. So there's 1, 2, 3, 4, 5, 6. So yeah, 6 R's later, we're at 125 over 64. So the 125s are kind of ugly, but that's kind of helpful. R to the 6th is 1/64. I sure hope 2 to the 6th is 64 because that gives me a nice fraction. Plus or minus a half, but that alternating thing means it's going to be negative because we're alternating. Okay, now did we answer the question? No, because it asked for the 14th term. So I could start with the 10th term, and I need to 11, 12, 13, 14. I need to do 4 more R's to get to the 14th term. So times negative 1/2 to the 4th. Let's see. I think 2 to the 4th is 16, but rather than doing 64 times 16, I think I'm going to start with 64 and multiply by 2 4 times.
Wait, isn't that like the 4th number? So you have to go back to the first.
But I'm starting with the 10th term and going 4 steps away. So you can kind of slide wherever you want. I could have started with the 4th term and gone 10 steps away, but then I'd have had to deal with 1/2 to the 10th. Which is actually what I've got to deal with anyway. 64 times 2 is 128, 256, 512, 1024. So 125 over 1024 for our 14th term. And again, Ohm, you're right. We could have backed up all the way to, let's see, that would have been 250 and 500 and 1,000, and then multiplied by 13 R's, or we could have started at the 4th term and multiplied by 10 R's, but we just wanted to pick the closest term and multiply by 4 R's. So again, once you get the hang of sliding around back and forth, it's just how many steps does it take to get to the term you want. Okay, consider the finite series This is another one where I don't think this derivation is worth it. Let's not do this one. Like, we derived the arithmetic sum by taking the average times the number of terms there are. This one is not worth the effort in my mind. And you'll see why when you get the final answer. So that's the sum of the first however many terms of a geometric Gotta know that. You know what, while we're here, that's the geometric sum. Let's go ahead and write the arithmetic sum right next to it. It's supposed to be clarifying rather than confusing, but this is the one that I can sort of memorize by understanding. This one I just straight memorize because that's kind of weird. But the arithmetic sum, that was the one that's the average times however many terms there are. You know what? While we're summarizing things, you can also see some parallels between the terms for geometric and the terms for arithmetic. So I'm highlighting the ones that you have to memorize. The other two you can get by without memorizing if you understand what's going on. But some people just memorize all four, and that's fine too. Okay, but this is the new one today, so this is the one that we'll work with for a few examples here. Yeah, that one you just have to memorize. That one I don't. Again, I know how to derive it, but it's just not worth the time to do it. Number 8. Find the sum from n equals 4 to 14. Here's a question for you. How many terms are there? If we go from 4 to 14, 11. Good. All right, so we're keeping it straight. Like, if you want to get from the 4th term to the 14th term, how many steps is it? If you're going from step 4 to step 14, how many steps away is the 14th term? 10. But if you want to add up from term 4 to term 14, that's 11 terms. I don't know that we need that for this problem, but again, that's the confusing part here of like, how many terms are there? How many steps are there? Not exactly the same question. Okay, that formula was A1, 1 minus r to the n over 1 minus r. Okay, actually we will need the number of terms, so I'm glad I asked that, because n is the number of terms. So to use that formula, I need the first term, I need n, which is the number of terms, and I need r. So we already said there's 11 terms. We got that one down. 14 minus 4 plus 1. 11 terms. How am I going to get the first term? What am I going to plug in to find the first term? 4. Okay, so this is kind of weird. We use A1 in the formula, but it doesn't mean plug in 1. It means the first term. And so this feels a little bit weird. The first term means plug in 4 for this one. Let's see, so that would be 2 cubed is 8. So my first term is 8. There's 11 terms. And then what's the What's the common ratio? 2. Hopefully you can tell by looking. If not, then you find the next term. That's 16 and realize, yep, R is 2. Alright, so S of n is the first term, A1, which is 8. 1 minus 2 to the 11th. Oh, that's lovely. Over 1 minus 2. We just did 2 to the 10th. It is. 2 to the 10th was 1,024, so 2 to the 11th is 2,048. One minus 2 is negative 1. Uh-oh, wait a minute. I forgot the 1 minus in there. So excited to figure out what 2 to the 11th was. So 8 times negative 2047 over negative 1. What did you say it was?
Negative 16,376.
I kind of like that answer.
I didn't do it
Okay, over negative 1. Okay, that's fair. You multiplied the top and got negative, and then when you divide by negative 1, it turns into a positive. Yes. That's a really big number. Let's think about what this means and see if that makes sense. We said our first term was 8. We're multiplying by 2, so our next term would be 16 plus 32 plus 64. It's like, okay, yeah, this thing is kind of blowing up on us here. We're just adding bigger and bigger powers of 2. So, I mean, I could write out 11 terms and then add them up by hand to see if that's right, but I just wanted to get a check to see if this seemed right. Adding bigger and bigger numbers, yeah, this thing is just getting bigger and bigger. What's that?
You have to check it.
What, do you have to check it?
Yeah.
No. And I only sort of halfway checked it.
Yeah.
Right? Like, what would you do if you really wanted to check it?
Go to that, actually do all of that.
Right? Like, keep adding terms until you get to 11 terms. So 128 and 256. And so you could really check that one, but no thank you. I checked it enough to make sure that my answer made sense. Number 9. Find the sum from 1 to 10 of 1/2 to the n. Okay, so same formula, which means I need the first term, and I need n, and I need r to use my formula. So what's the first term? Careful, this one doesn't have n minus 1 up there, it just has n. So a1, if I plug in the bottom number, I get 1/2. How many terms are there if I start at 1 and go to 10? 10. And r is 1/2. Okay, so I think I'm ready to use my formula now. S10 is the first term, 1/2. 1 minus 1/2 to the 10th. We really like our 2's and big powers today. Over 1 minus 1/2. Well, there's at least one nice thing about the formula. See anything that's... The 1/2's cancel, so at least there's that. And then 1 minus 1 over 1024 was 2 to the 10th. So I can do a common denominator on this problem. 1024 over 1024 minus 1 over 1024 would be 1023 over 1024. Man, that's really close to 1. It's not 1. It's close to 1. let's do that kind of reality check on this one and see what happens. So if I start adding these up, that would be 1/2 plus a 4th plus an 8th plus a 16th plus dot dot dot. I don't want to do that 10 times. So did we do the paint the wall problem in this class? Paint the wall? You got a big wall in your room. So on day 1 you say, oh, let's paint half of it. And on day 2 you say, let's paint a 1/4 of it. Let's paint half of what's left. And on day 3 you're like, I'm getting tired. Let's only paint half of it. And then day 4 you're like, I'm really getting tired of this stupid wall. Let's only paint half of it. And
there'll always be an infinitely small.
right, so it's like you never paint the whole wall, but you're getting closer and closer to 1. And in fact, after 10 days, you've painted 1,023 out of 1,024th of the wall. Yeah, after a few more days, you're going to be like getting your toothpick out to put the dot in there.
Isn't that called the golden spiral? It's not, or is it? There's golden something.
It's probably got some name to it, yes.
And I like the A4 papers.
Okay, so like big picture here, look what happens, the difference between 8 and 9. Number 8 was kind of blowing up on us, and number 9 was doing what, this is a huge deal in calculus next year, is converging, like it's headed toward 1. We don't get there, but it's converging, it's headed toward 1. What's the difference between 8 and 9? What makes 8 blow up and 9 converge?
Less than 1 or greater than 1?
It's what R is. If R is bigger than 1, then the thing kind of blows up on us. If R is less than 1, then our numbers are getting smaller and smaller, and so the sum converges. We are right on the edge of like second semester Calc PC with this stuff. So we better stop there. Actually, let's go one step further. Consider the sum of a geometric series, 1 minus r to the n. Okay, if r is less than 1/2, or excuse me, if r is less than 1, what does r to the n become if I've got like 1/2 to the 437th? Yeah, it's headed toward 0. And so this is a little bit tricky because if we have an infinite sum, this would be impossible to check, right? Because you can't write out all the infinite terms and then add them up, because you eventually got to stop somewhere. But if we could add them all up, that r to the n would be headed towards 0, and then you get a much simpler formula. Now, be careful, this is only for a geometric infinite series with r less than 1. So it's a great formula, but it's only for geometric, only for infinite, only when r is less than 1. So, nice formula, but pretty narrow when you get to use that formula. I don't like that it says A. I wish it said A1 there. That's usually how we memorize it. It's just the first term over 1 minus r. Which is kind of weird that the infinite formula is a lot easier than the not infinite formula. Right? It feels like, or it just seems like infinite should be trickier than not infinite. But for this formula, because that goes to 0, the infinite formula is easier. You guys got Dia under control over there? Trying. Number 10. Find the sum of the series. N equals 0 to infinity. Okay, so infinite means I'm thinking I can use my infinite geometric series formula. but only if r is less than 1. So r is 1/2, so we're like cleared to use the formula. What's the first term?
3/2.
Careful. What's the first term?
3.
I've heard 3/2, I've heard 1, and I've heard 3. 3.
1/2 to 1.
Because 1/2 to the 0 is 1.
1 times 3.
Times 3 is 3. So be careful, this one started at 0, which makes the first term plug in 0. So 3. So the infinite sum would be 3 over 1 minus 1/2. 3 divided by 1/2. Keep it, change it, flip it if you like, or how many times does 1/2 go into 3? 6 times.
Isn't that weird how the sum of an infinite thing is 6?
Yes. Yeah, you should be thinking this feels strange because we just added up an infinite number of positive numbers. Like, so we didn't like cheat and add in a bunch of zeros or negatives that would cancel things out. Like, we added an infinite number of all positive numbers and landed at 6. That should feel weird.
Wouldn't it be like technically slightly less than 6?
Okay, so that's the other thing. It's like, well, isn't it a little bit less than 6? If you ever stop counting, yes, it's a little less than 6. If you don't make it to infinity, you are shy of 6. That's true. Now, you're like, well, how do you can't make it to infinity, but if you could, you'd get to 6. You certainly can't go beyond infinity. So this is definitely weird stuff, and it should like boggle your brain a little bit. Like, wait a minute, we're adding an infinite number of numbers, and we're landing at 6, but do we really get to 6? Kinda not. If you ever stop, you'll never get to 6. If you wanted to check this one, let's see, our first term was 3. So 3/2 and 3/4 and 3/8. Like, you would never make that land at 6 because at some point in your calculator, right, you'd have to hit enter. 3 plus 3/2 plus 3/4 plus 3/8 plus 3/16. And if you could do that forever, then yeah, you'd get 6. But at some point you have to stop and hit enter and say, well, that's pretty close to 6. And it's not 6 because I didn't add the rest of the terms on there. I stopped at the 4th or 5th term. So you can kind of check them, but be careful. Why don't you try number 11? Number 12. How do you want to do number 12? Let's see, the first term would be 5 squared is 25 times 2 is 50. What's r equal to? 5. So the infinite sum. What's that? I think you're right, Victoria. What'd you say?
Can't do that
Why can't I do that?
because it's greater than 1.
Right. You can't do this. R is greater than 1. So that formula doesn't apply. And if you wrote out a couple terms, you'd figure that out pretty quick, right? Because your first term is 50, and your next term is 250, and your next term is 5 times that, and you're only 3 terms in, and it's already blowing up. So no. And the fancy way to say that is this series diverges to infinity. It means it's headed toward infinity. And so even on the diverging one, you would say it never gets to infinity, right? You'd have to get all of them to get there.
This is Matt National. Please stand for the pledge.
All right, so number 13 has got some weird numbers in it, but it works. The main thing was checking that e over pi is less than 1, so that we're good to use it. All right, so today's assignment's worksheet 3. The good news is tomorrow all I'm going to do is answer